Hello guys, welcome to this session on data visualization with Python. Uh, Today we'll be going to discuss about a very important visualization library which is very fundamental and it is the foundation of all the data visualization methods that we see in Python. So the name of the library is MatPlotLib. uh, as you can see over here. So this lecture or this session is about how to plot different kinds of graphs with MatPlotLib and what are the functionalities of MatPlotLib, what all can we do with MatPlotLib. So like before starting with anything, I would like all of you to go ahead and look at the documentation of MatPlotLib, right? So it's here. You can just go to matplotlib.org and you can look at the website. So as you can see, it allows you to create, customize, and extend different kind of visualizations. You can look at the complete user guide, how to use different functionalities, different methods and functions of this particular library. You can very well go ahead and join the community to post your queries, to answer some of other people queries. The important page here is that I want you guys to look at for sure is examples. So this page shall take us to a collection of all the kinds of graphs and plots so that we can draw or that we can make using this matplotlib library. So as you can see, like stacked bar and chart, grouped bar and charts with labels, plotting the coherence of two signals, right? Like this kind of filled polygon graphs, hedged filled histograms, join styles and cap styles. So there is a huge number of options uh, available in Matplotlib for any application that you can think of, whether it is going to be a product presentation, whether it is going to be a signal analysis, whether you are doing some visualization about the weather data or maybe sports data, about some players performances, whether you want to make a heat map. Or so as you can see, there is a lots and lots of types of graphs and plots that you can make using matplotlib. So I want you guys to go through this documentation and keep referring to this documentation for any of your further uses, right? One more important page that I want you guys to look at is the tutorials page. Tutorials page will give you a usage guide if you want to do something with the pyplot, how to go ahead with that. And it is level wise, like introductory, then you have intermediate, then you have advanced plottings, then how to play with colors in matplotlib, right? And you can also draw some text over here, right? So also I just want to go back to examples. And why this examples tab is really important is that suppose you want to plot this particular horizontal bar chart. So if you click on it, you will get an example, okay, how your graph is going to look like. It is like horizontal bars, and below the graph you will find a very well commented code which you can directly just copy. You see option to this option here top right, you can just copy this code and you can directly reproduce it. It is very well commented, right? So you can download the Python source code, or you can download the Jupyter notebook directly, right? So I want to go back to the lecture and let's start, right? So Matplotlib is the grandfather library of data visualization with Python. Why grandfather? Because all the other libraries, like complete data visualization concept in Python, is based on or built upon this particular Matplotlib library. So we will be looking at Seaborn, which is another very advanced data visualization library, very popular in Python, and it is also built upon Matplotlib. And we will also look at some other visualization libraries too. So that's why it is called the grandfather library of data visualization in Python. So it was created by John Hunter. He created it to replicate MATLABs. So MATLAB stands for Matrix Laboratory. It's a completely different programming language or a software or a tool which is also used for data analysis, robot simulations, and many other kinds of simulations and analysis like Simulink. So it is also very popular. So Matplotlib is kind of a replication of MATLAB's plotting capabilities in Python. So if you know MATLAB, then you will feel more connected, or you will feel you can understand like it is very much the same as Matplotlib is very much same as the MATLAB. Otherwise, we are going to understand or go through the complete process how to do plots using Matplotlib. So it is an excellent 2D and 3D graphics library. You can create both kinds of graphs, 2D and 3D graphs, right, for generating scientific figures. Some of the major pros of Matplotlib are it is generally easy to get started with simple plots. So like it's very simple, within just one or two or three lines you can plot your very first graph. It has support for custom labels and text. So it is like it gives you the capability similar to a painter. So when you are drawing or painting something on your own on a white sheet of paper, you have all the controls. Okay, you can decide what should be the texture, or what should be the, what kind of drawing you want to draw, you have control over that. What should be the colors you want to fill, you have control over that. What should be the border line, what should be the border width, what should be the color of the water, how, what shade do you want, what shape of the trees you want. Just like a painting that a painter draws, you have all the controls in Matplotlib over a graph, over a plot that you want to make, right? So great control over every element in a figure. So you can control absolutely everything about a figure in our our respect can be a plot or a graph. Okay, we will also look at there are different types of graphs. So it gives you high quality outputs in many different formats. So many different formats, as in you can get a JPG, a PNG, a BMP. So in all different formats, you can get your output, and it is very customizable in general. Right. So Matplotlib allows you to create reproducible figures programmatically. So it allows you to draw figures programmatically. Just like in our school, we used to draw graphs on a graph paper, which has all those grids. We need to draw, like connect some points. We need to draw a graph or plot something using ruler and scale. Here we can do that, all that programmatically. Right. Let's start learning. And this is the website link, which I have put in the uh, Jupyter notebook for you all to go ahead. So if you have installed your Python using the Anaconda distribution, then like most probably Matplotlib is by default installed along with the Jupyter distribution. Otherwise, if you are using some other version of Python, you can just directly go to your Anaconda prompt and type this command conda install Matplotlib, and it should install Matplotlib in your computer, in your system. Or if you are not using Anaconda distribution, then you can directly just go ahead with pip install Matplotlib in your command prompt or console or terminal if you are working with Mac. So just like a ritual, everything in Python in Jupyter starts with importing some libraries that we'll be using. So here we will be importing matplotlib.pyplot as PLT, right? So we will be referring to matplotlib.pyplot module or function as PLT in our Jupyter notebook. So it's a very accepted practice. All of the Python practitioners use this notation for Matplotlib PLT, right? Then we have to do this percentage Matplotlib inline to see our plots just in the output cell, right? And if you are not using Jupyter notebooks, if you are using Spider IDE or maybe PyCharm or some other Python environment, then you have to write this particular line after every plot, after every graph. You have to do plt.show to see your graphs, right? Let's go ahead with some examples, right? We will be creating two variables. So I will need to import numpy as np because I want to create two variables which will hold some numbers. So yx is equal to np dot linspace. So I want to create a linear space starting from 0 go up to 5 and give me 11 points, right, which should be linearly spaced, and y becomes x square, right? So this is what my x looks like. These are 11 points, and y is x square, right? So it's an array. Both of them are an array. Now to plot something in Matplotlib, I can go ahead directly with plt.plot. So plt stands for matplotlib.pyplot, and I can call this library and dot plot. I want to plot x variable with the y variable, and as the third argument, I can directly pass the color. So in this quotes, R stands for red in color, right? I can just with this one line, I can get this particular graph, right, this particular plot. And if I want these titles like x-axis, y-axis, and the title of the graph, I can go ahead and add x plt dot x label should be this, plt dot y label should be this, plt dot title, that what should be the title of my graph. It is like this string title over here, and I can use plt dot show, right, to see my graph. Otherwise, if I don't want to use it, I can avoid using it. I can just do like this, right? So I get an output cell. So if because I have done this particular line over here, percentage matplotlib inline, then I'm able to see the output in my output cell, right? So otherwise, I have to see the output here, I have to use this line plt dot show. So if I do plt dot show, there is no out cell over here. It is like printing my graph. If I don't use this, then it is like I'm getting an output of this particular part of the code, right? This is how we plot any graph using matplotlib. Right now, next step is to suppose we want to plot multiple graphs on the same canvas like this. So I want a graph on the left hand side and a graph on the right hand side. How can I do that? So to do this, I will call plt.subplots. Subplots. Then I want one row and two columns, and this should be the plot number, right? So plt, the for the syntax is like this: plt dot subplots, that means divide my canvas into subplots, like small plots. And what are the type, what in what structure I want my plots is like this. So I want n rows, I want one row and two columns, right? Two columns. And currently I am working on the plot number one. That means I'm working on this plot. Now in the next line we can write plt.plot x with respect to y, and the structure should be like this. So I want red dashed lines. Okay. So like with the color, I can define what kind of my line graph plot lines should look like. So I want dash dash dash, right? So this particular these two lines are responsible for this left hand side of the plot. And when I do plt dot subplot, one column, one row, two column, and I'm talking about the second plot. So this line takes the focus to this particular plot, and this particular line plt dot plot y with respect to x, green color star dash is plotting this particular graph on this particular pattern on this right hand side graph, right? So the important thing to remember is this subplot method. I can call subplots to divide my canvas into smaller plots, and I should give number of rows and number of columns, right? How many rows I want, how many columns I want, and the plot number on which I am working. Okay. So this was the direct method of working with MatPlotLib. There is also a better way of working with MatPlotLib, which is called the object-oriented method, right? So let's see how does it work. So like the general concept of object-oriented method, in MatPlotLib we create an object called the figure, right? So fig is my variable, which is a figure object, right? plt.figure, right? So now I have created figure. A figure object called fig, and it is kind of a blank sheet of paper. And now I want to add axis. So I want to axis is equal to fig dot add axis, right? I can add axis. So it is like on blank sheet of paper, I'm drawing those two perpendicular lines, y axis and x axis, right? And just like any painter, I have the freedom to choose where my axis should be. So I will pass an argument which in the form of a list, which will have four values. So the first one is the percentage from the left hand side. So where should be my axis, where should be the center of my axis from the left hand side? It is like 10%. And what is the percentage of the axis from the bottom? Like the distance between the bottom of the canvas sheet and my axis is like 10%. Then what should be the width of my axis, what should be the height of my axis? So these four parameters I can define, right? So if I draw this, I get a graph, I get a blank axis sheet like this. Let me just comment out all this code for you. So if I comment this out, if I run this, I get a blank sheet, right? So just with this, so let me just comment this out also. If I run this plt, so if I just created a figure object, now I see the output is figures of size, this particular size, with zero axis. So it now in the memory of the computer, this particular line of code has created an empty canvas. Now I want to add a axis. So I can add an axis like this, right? I can change these parameters to get a different axis. So I want to, the distance should be 50% from the left, 50% from the right, and the size should be what? Let's say 2%. 20% and 20%. So if I make this, so this is what my graph looks like. Okay, so with this I can play with this to change the shape and size of my axis, like 80%, maybe 90%, and 90%, right? This is now I have a bigger graph like this, right? So now if I want to plot something on this, I can directly plot just by using the axis object. Okay, so I can use the axis. So to plot, I think I need to address axis. Unlike here where I was using plt.plot, here I will be using axis.plot, because I will be plotting anything with respect to axis. So here I'm plotting axis.plot. Axis is this axis which we defined earlier. Axis.plot x with respect to y, it should be blue in color, right? Then axis.set label. It is different from this plt dot x label y label, right? Plt dot x label y label. Here the name is a bit different, but the work is same. I am doing axis dot set x label. What is the x label? Axis dot set y label. What should be the y label? Axis dot set title. So it is giving names to your title like this. So I have a blue graph of x with respect to y. Here the goes the name of the x axis. Like it can be salary, then it can be like expenditure. Okay, and the title will be salary versus expenditure. Okay, so let's look at how can I plot multiple plots like this. So suppose I want to make a graph which have a bigger axis and a smaller axis which is inside of the bigger axis. How can I make a graph like this? Right, so I'll start with and I need to create a figure object or a blank canvas, blank sheet of paper on which I want to draw. So I will do a fig is my variable, which creates an object of figure, type figure, right? So plt.figure creates an empty canvas. Now I want to add axis, right? So axis 1 will be like figure dot add axis. It is the bigger axis, it is like this main axis. And axis 2, figure dot add axis, it's a smaller inside axis, right? Here in the comments you can see. So this so axis 2 corresponds to the inside axis. Axis 1 corresponds to the bigger outside axis, right? You can try to play out with these numbers, like you can change it to 0. 0.5, 0. 0.5, 0. 0.5, 0.5, and see whatever happens. You can also try to move this around. Okay, so currently it looks like this, right? And on the axis 1 I am plotting x with respect to y in blue color, right? And on x, and the title is axis 1, and on axis 2 I'm plotting y with respect to x in the red color, right? So this is axis 2, this bigger one is the axis 1. Now let's play around with this. So I want to be this to be at the 0.5, 0.5. Now it shifted over here. Now let's try to bring this particular inside graph to the bottom, almost like bottom of the plot. So let's put a 1 over here, because it is like from left hand side, from the bottom, what should be the width, what should be the height, right? So let's do this. So now it came at like it is almost at the bottom. Now let's try to increase this in size. So let's do it 0.5 and 0.5, right? So now it became bigger like this. Okay, so this is how you can play around with this particular so let's make it back to the original. It was what, zero point 0.4, I guess. This was 0.3, this was 0.3. Okay, let's move a bit more left. So let's do 0.2. Okay, sorry. Okay, there's an error because there is a comma missing over here. Okay. See, this is the graph is my graph is back. So with this way, you can add multiple axes. So you can also add a third axis on here also, or a fourth axis. You want to have a plot somewhere here or a plot somewhere here. You can do all that. Just like it is almost like we are drawing this axis with a pencil and a ruler on a white sheet of paper. You have all the controls, right? Now let's look at how to work with subplots. Right, so we previously used to use plt.figure. Right, now I can directly use tuple unpacking is like assigning two values in just one, using just one equal to sign. Right, so I can assign a figure object and an axis by using plt.subplots. So by doing this line, I have created a figure object and I have also added some axis to it. Right, now I can do axis.plot x comma y in the red color. Now I can set the x label, I can set the y label, I can set the title. So I can get a graph like this. Okay, this is a more professional way of doing this. So suppose now I want multiple graphs, so I can do figure comma axis is equal to plt dot subplots n rows is 1 and columns is equal to 2. So it will give you two blank graphs like this, right? Now it has two axes, but there is only just one figure, right? So my axis here is a collection or is kind of a list. So if you look at axes, it is a list. So there is one axis at this location, then comma another axis at this location. So it is an array object. So I can iterate over these arrays like in a for loop. Okay, so for axis in axis, plot x with respect to y, set x label, set y label, set title. So I can plot my figure like this. Okay, so this overlapping can be solved by using something called plt dot tight layout, which we will look at later. Right, a common issue with MatPlotLib is overlapping subplots or figures. We can use fig dot tight layout or plt dot tight layout method, which automatically adjusts the position of axis on the figure canvas so that there is no overlapping content. Okay, so this is the same graph, this is the same graph previously. I have just added this particular line. Now the output looks much better. There is no overlapping y, which like this. Here y was overlapping. It is the same code, right? Like this. So here the only difference is that axis is a collection. It's an array because we are using subplot and there are two plots. So axis object will is like an array. You can use indexing or you can use a for loop to plot, or you can directly call them by index. Okay, so Matplotlib also allows us to work with the figure size, the aspect ratio, and the DPI. So DPI is so figure size is like whatever how like the height and width of the figure. Aspect ratio is so like you if you are using a phone, you have to click pictures. You see like okay, what should be the size, what should be the horizontal and the vertical no, size of the picture. That's the aspect ratio. You see this in TVs also, right? A DPI is dots per inch or the pixel per inch. So it is the clarity. So more number of pixels, that means more the clarity, right? So Matplotlib allows the aspect ratio, DPI, and figure size to be specified when the figure object is created. You can use the fig size and DPI keywords argument, right? So fig size is a tuple of width and height of the figure in inches, and DPI is dots per inch or pixel per inch. So when I'm defining my figure object, so in the argument I can pass what should be the figure size and what should be the DPI. Okay, like this. So it says a figure of this size 800 by 400 is created with zero axis, right? The same argument can also be passed to layout managers such as subplots. So I can also pass the same argument of fig size and DPI in subplots. So I can do fig comma axis is equal to plt dot subplots. The figure size should be 12 by 3. So 12 is the width and 3 is the height. Okay, so I can get a plot like this. So 12 means like it is more wide and it is less high, right? And I'm plotting x with respect to y in red color, right? So I can get a graph like this. Also, while you are doing some analysis or working on some particular problem which needs plotting, so you also need to save your plots so that you can show it to your manager or you can show it to your clients or you can show it to put your graphs in presentations. Or if you're working on some if you're doing some research, you need to put this in some paper. So you can also save your figures, right, in all of these formats, in PNG, JPG, EPS, SVG, or even PDF, right? So you can do save like this fig.save file, and you can create a file name, right? And you can directly save with your file like this, right? So this is your plot which we have created, right? So it depends. So this is the current. It is very big in size. You can use it as per your convenience. So you can do all you need to do is fig.save file. Then also you can define your DPI here. So currently this file is very high, like big, because you can see all the numbers very clearly. Even it is very zoomed in. So it is because we have used a DPI of 200, right? The by default DPI is 100. Next comes legends, labels, and titles. So legends is, suppose you are plotting multiple plots within the same particular graph, right? There are multiple lines, multiple curves. So you need to designate or denote each and every curve. Okay, this curve is curve 1, curve 2, curve 3, or this one is means apples, this means oranges, this is the graph for uh, mangoes, right? Labels are the X label, Y label, and titles. Okay, so how can you, to how can you set all these? So to set access, I can do access dot set title, right? And to do for doing access labels, I can do this. We have already seen access dot set label, access dot y set y label. I can set x and y access the name for, like, what does this signify? Okay, like price versus expenditure, or height versus weight, or marks versus attendance, like that. Okay. And now suppose I want to, so there is, I'm creating a figure object, plt.figure, and I'm adding an axis, fig.add axis, like this, with this particular configuration, and I'm plotting x with respect to x square, x with respect to x cube, and x with respect to x to the power 4, and the label are these. Okay, maybe like this, x square, x cube, x4, and I can just directly do x dot legend. Then I can see, so there are like three lines I'm getting here. So the colors is assigned by default. I'm not defining colors over here anywhere, right? So this orange, blue, green color is assigned by itself, and there is a legend which I can see top left. Okay, so like blue graph, blue color, blue line is for x square, orange curve is for x cube, and green color is for x to the power 4. So like with just simple line of code, we get this nice beautiful graph. And I can also add what is x label, what is y label, what is the title of the graph. Okay, so also I can also, I have MatPlotLib provides us control over the position of these legends. Okay, so like you do, whether you want your legend to be here or here or here or at any other location, right? So if you do add axis dot location, so let's, now if you run this, if you run this, okay, it says no handles with labels found to be put. Okay, let me, I have to run this first. Now I can run this, right? If I run this now, so I have to like uncomment this to see my figure, right? This is my figure. Okay, so now my legend is at this particular location. Right, now let me comment this out, and let me uncomment this. If I run this, my legend is at this top left. Right, so I can have to keep changing this location to so now let's comment this and comment this, and I run this. My legend is at this particular location, bottom left. Right, and I want to put it at a different location. I can do like this, bottom right. Okay, or if you want to, if you don't want to waste time on it, you can just let matplotlib choose by itself. Then you can just do axis dot legend, loc should be 0, so it lets matplotlib to decide the optimal location. Okay, you can, to look at more about legends, you can go through this documentation page. It tells you about like how all the ways in which you can define and describe your legends. Okay, so I have provided the link in the comments over here, documentation page. Right, next is how can I set colors, line width, and line types. So line type, so like colors is, are these green, orange, and blue colors. Like how can I define what kind of, in what ways I can give color to my graphs. Line width, so what should be the thickness of these curves, these plots that I'm making. And line types, what are the different shapes I can give, what are the different types of line I can get. Okay, so like just like a MATLAB like syntax, I can provide blue color, green color, like this. So like just simple B, simple G. Okay, and I can also provide so I want, if I'm plotting x with x square, then I can do b dot dash, that means blue line with dots. I can also give g dash dash, that means green dashed line. So if you run this, you get a plot like this. So the blue line with dot and dash, and a green line with dash dash. Okay, so you can provide a color like this. Or you can add a parameter. So when you are doing axis dot plot, against the plot, you can provide color parameter, what color you want. So blue, you can pass the complete string, and you can provide a alpha value. Alpha value defines the transparency of your plot, right? Okay, so like this you can or you can provide the hex code, RGB hex code. Suppose if you are a designer, you work with Photoshop, or you need a specific shade of orange, then you can directly pass the hex code also in the color parameter. This is a very good functionality. So instead of just saying blue, you want a specific shade of blue, so you can go to like Paint or Photoshop, you can pick the exact hex RGB hex code, and you can pass the hex code as the color parameter. Alpha parameter stands for the transparency of the line. Suppose there are multiple plots which are overlapping, and you don't want to hide the graphs which are below some other graph, you can use the alpha value or the transparency value. Next comes the line and the marker styles, right? So same, it is like same plot. So I'm creating a figure and axis by using plt.subplots. The figure size is 12, should be the width, 6 should be the height, and I'm plotting axis.plot x with respect to x plus 1. Color should be red, line width should be 0.25, and the rest of them are like same. Plot x with respect to x plus 2, color should be red, line width should be 0.5, line width should be 1, line width should be 2, right? And next I'm plotting x with respect to x plus 5, color should be green. So the short for line width, I can directly use lw should be 3, and line style is dash, right? To give line to give the line style parameter, I can directly use ls for line style, dot and dash. Ls should be like colon. And if you want to create a custom dash, then you can do line is equal to axis dot plot x with respect to x plus 8, color should be black, line width should be like 1.5, and line dot set dashes. This is the space, this is the format. Okay, you want what should be the line length, what should be the space length, line length, space length, like this. Okay, you can also give markers, right? What is the marker you want to use? So I want to use marker as plus, or I want to a circle or a square or like one. Okay, these are all the marker types that you can use, right? And I can also give marker size and color. So basically just have a look at this graph. So I can, so this line, the bottommost line, the transparency is the line width is 0.25, line width is 0.50, line width is 0.75, line width is 1, line width is 2. The color is changing, the line style is changing. Okay, this is dot and dash, this is just dash, this is the custom dash that we created. Okay, and I can, so these are the markers. Like circle you want to use, I, or you can want to use a square, like this one is using a square. So I can define my marker size. Okay, so I can divide, marker should be O, marker size should be 2. I can also define what should be the marker face color. So here the marker, what should be the color of the marker face? So here the color is purple for the line, the line width is 1, the line style is dash, but the marker is a circle. Okay, and the marker face color is red. So this is what my line looks like. And here suppose I want a marker to be square, the marker size is 20. I want to give the face color as blue, and the marker edge width is 5. Edge width is this one, the topmost graph, and the marker edge color is yellow. So the marker edge is yellow, it is of square shape. The marker face color is blue, and the width is 5. So you can try out, play all with all these parameters to see how it works for you. Here next top thing is how the control over the axis appearance. Suppose you want to limit, you want to put a limit like up to where you want to see your x-axis and your y-axis. So you can set limit, x limit, set x limit, set y limit methods in the axis object, or the axis dot tight for automatically getting tightly fitted axis range, right? Suppose we are making a figure and axis, plt dot subplots, I want one row and 3 columns, and the figure size should be 12 by 4. On the axis 0, I'm using indexing to axis. So axis 0 stands for this particular graph, axis 1 stands for this particular central graph, axis 2 stands for this particular graph, because I am doing subplots. There is 1 row and 3 columns, so I can, and axis is an array. So I can do indexing to fetch to work with all the axes, right? So on the axis 0, I'm plotting x with respect to x square, and I'm plotting x with respect to x cube. So this is also a very nice notation. I can plot multiple graphs by like in just one line. I can, so I want two plots, x with respect to x square and x with respect to x cube, and this is the default x ranges. This is a set title. Next, I'm plotting x with respect to x square, x with respect to x cube, and I'm doing axis in bracket tight. So it means like it will all automatically fit all the axes, uh, axis ranges. Okay, now in the third plot I want to do custom range like this. So like here the x-axis is 0 to 5. In the central graph also the x range is 0 to 5, but here I want to see just between 2 to 5. And the y-axis, like on both left and central graph, are from 0 to 120, but on this custom range I want to just see from 0 to 60. So I can set the limit. So I can set the y limit to be 0 to 60, set the x limit to be 2 to 5, and I can set the title as custom x ranges. So all of them are showing the same graph, but the rightmost graph is showing the different x limits and the different y limits. Okay, now we also see so the we can also plot some special types of graphs, just like if I do plt.scatter x with respect to y, I can get a scatter plot like this, or I can do a histogram plot like this using so let's create a sample data in a range, like give me in the range of 1 to 1000, give me 100 numbers, and I can plot a histogram of the data like this, right? And or I can do a box plot of the data like this, but like we'll be using other very advanced library, which is uh, a seaborn, for plotting the different kinds of graphs. Okay, and I have some links, very nice links over here, which I want you guys to go through, have a look at these documents, right? And this is all that I have to discuss with MatPlotLib. Thank you for your time. I'll see you in the next lecture.